Algebra 2, Chapter 8, Section 5, Variation Functions. We've learned about direct variation in the past. We learned about it in Algebra 1. Um, we may have even talked about it this year. But the whole idea is that it can be expressed as y equals kx, where k is just the constant of variation. One way to describe this is also by saying the ratio of the quantities is constant. So think about this equation, y equals kx. Divide both sides by x, you have y over x equals k. The ratio of two quantities, x and y, is constant. So um, we usually do a couple things here. We're usually doing, we usually try to find k, then we write the equation, which means it's going to be in that form. And then what we usually do is we find a new value. So those are the three things that we usually happen. The first two are usually considered together in a group. So we have to find k, then we have to rewrite it in an equation, and then we use that equation we just found to find a new value. So that's the things that we're usually doing with this kind of problem. Example 1, if y varies directly uh, with x, so as soon as I read that line, I think y equals kx. Those words tell me that equation. Uh, um, oh, so it's, I think I typed it wrong. It should be, I always say with when I'm saying it verbally, but it should be y varies directly as x. There we go. All right. And then they give us a couple values. They give us y equals 15 and x equals negative 5. So what I'm going to do is I'm going to plug those two numbers in. Y is 15, x is negative 5, and now I can solve for k. Divide both sides by negative 5, you get k equals negative 3. So my equation is y equals negative 3x. And now the third part, this is what I was saying, how there's multiple parts to these things. We're going to find y when x equals 7. So now I have my equation. All I'm going to do is find y when x equals 7 and y equals negative 21.